Okay, we should be live. Should be live. Should be. Just let me know if you checked out BioniChaos.com. If you did, let us know if you have any questions. We can address them straight away. We can address them straight away. Hey, what do you see on the screen?
I see a web page titled BioniChaos Biomedical. The site appears to be about biomedical data, technology, and education, and it lists several tools like an interactive prosthetic arm simulation and a K-theory analogy.
So this is the website we develop, and those are the last 3 tools or 4 tools that were from the last week or so, or 2 weeks or so.
Thanks for letting me know. It's interesting to see the tools you've been working on.
Can you review?
Certainly, I can review the tools listed on the website. Which one would you like me to focus on?
All of them.
Okay, I can briefly review each tool. The Prosthetic Arm Interactive Simulation is an educational simulation of a prosthetic arm demonstrating key concepts in robotic manipulation. The Interactive K-theory analogy is a web application that visualizes the core concepts of topological K-theory. The ultrasound simulation game, A Medical Exploration, is an interactive ultrasound simulation with a dual-panel display and B-mode imaging. The real-time signal amplification microscope is a web application that uses Eulerian video magnification to visualize subtle changes in skin tone and extract pulse signals. And the Advanced EEG Signal Simulator is an interactive simulator that generates real-time EEG signals. Is there anything else I can help you with regarding these tools?
Which one's your favorite so far?
While I don't have personal preferences or favorites, the real-time signal amplification microscope sounds like a really interesting application of Eulerian video magnification. Which one seems most interesting to you?
Sorry, which one did you say is most interesting if you were a biomedical data scientist slash clinician?
If I were a medical data scientist or clinician, the Advanced EEG Signal Simulator seems like it could be particularly interesting because it allows for the generation and exploration of real-time EEG signals. This could be valuable for understanding different brainwave patterns. Would you like to know more about how this simulator works?
Why didn't you select any of the other 4?
I considered the other tools too. The prosthetic arm interactive simulation is great for robotics education. The interactive K-theory analogy visualizes complex mathematical concepts. And the ultrasound simulation game is a practical way to learn about ultrasound. However, the Advanced EEG Signal Simulator seemed the most relevant to your mention of medical data science or clinical work, due to its ability to generate and explore real-time EEG signals. Was there a specific reason you were curious about the others? That's an interesting question about the future of personal medical technology. It's possible that language models could assist patients in understanding their own data and even create simple tools. For example, a patient might use a model to generate code to visualize their EEG signals, similar to the advanced EEG signal simulator mentioned, or perhaps analyze patterns in their pulse rate using a tool similar to the real-time signal amplification microscope. This could empower patients to be more involved in their healthcare. What are your thoughts on the potential benefits and challenges of patients using language models for this purpose? Imagine using a language model to help you interpret the images from an ultrasound simulation, similar to the one described here, or perhaps getting help with understanding the mechanics of a prosthetic arm if you are interested in them. Do you think it would be useful to have that kind of personalized assistance with medical tools and concepts? What kind of information would be most helpful for you to understand personal medical data? Let's make it more fun. Imagine you could use a language model to turn your pulse signal, detected by something like the real-time signal amplification microscope, into a musical pattern. You could then use a language model to generate a unique melody based on your heart's rhythm. Would you be interested in exploring that? What kind of sounds or music would you imagine creating? Another idea could be using a language model with the advanced EEG signal simulator. Imagine being able to translate your brainwave patterns into a visual piece of art. You could customize the type of art based on your favorite artists or styles. Would you be interested in creating something like that? What kind of imagery do you imagine would come out of it? Let's consider the ultrasound simulation game. Imagine you could generate a 3D model of what you're seeing in the ultrasound, which could be printed later. You could use a language model to describe the model, or even create instructions for how it should be printed. Would you be interested in exploring that? What kind of objects would you imagine printing from medical data? Let's focus on the ultrasound simulation game again. Imagine you could generate a short narrative or a story based on the simulated diagnostic findings, perhaps describing the experience of a patient. You could even create a branching narrative where different diagnostic choices lead to different outcomes. Would you be interested in exploring that? What kind of stories do you imagine would come out of it? Sure. We're exploring how language models could be used with different medical simulation tools, like ultrasounds or brainwave sensors, to create interesting and interactive experiences. For example, with the ultrasound simulation game, you could generate a personalized medical narrative or even a 3D model of what you see. What specific part of that are you most interested in? On the screen, you see an ultrasound simulation. On the left, there's a probe that sends out and receives ultrasound waves, shown as yellow and green lines. It's interacting with representations of organs, like the red oval and blue circle. On the right, you see the resulting ultrasound image, where the white dots represent echoes reflecting from the organs. A language model could potentially interpret the shapes and patterns you see in the image, describe what they might represent in a medical context, or even generate a descriptive summary of what you're observing in the simulation. Does that make more sense now that you can see the simulation? Imagine we could add an interactive feature to this ultrasound simulation where you could click on different parts of the image. A language model could then generate information about what that area likely represents or potential medical conditions associated with it. This could make learning about medical imaging much more engaging and personalized. Would you be interested in trying out something like that? We could make it more concrete. For example, if you clicked on the red oval shape, the simulation could display information about different organs that are similar in shape and position, and provide details about specific conditions that might affect them. Or we could focus on how the different pulse types interact with the various shapes and the resulting image. What would you prefer? This ultrasound simulation visually represents how ultrasound waves interact with different types of tissues and structures. On the left, you see the tissue model, showing a probe emitting pulses and various shapes representing different densities. On the right is the resulting ultrasound image, built up dot by dot as the pulses return. To make this simulation more engaging, we could add an interactive element where you could click on specific areas in the tissue model. Then a language model could describe the potential tissue types, organs, or conditions that the shapes represent, along with brief medical context. This would transform the simulation into an interactive learning tool tailored to the specific areas you explore. Expanding on that, clicking on the red oval shape, for instance, could bring up information about organs like the liver or spleen. It could describe their normal function, common conditions that affect them, and how those conditions might appear on an ultrasound, perhaps with example images. Similarly, clicking on the blue circular shape could relate it to fluid-filled structures like cysts or blood vessels and provide insights into their appearance. We could even connect it to the different pulse settings, explaining how different wave frequencies are used for different depths and types of tissues. This approach would help bridge the gap between the visual simulation and the real-world medical applications of ultrasound. Let's make this simple. Imagine you can tap on any part of the left side where the ultrasound waves are moving. When you do, I would tell you what kind of body part that could be, like the liver or a tiny fluid sac. I'd then give you a quick description of how that part would look on a real ultrasound and perhaps some info about common issues there. Does that make sense? Would you like to try clicking on a specific shape? Sure thing. So, what part of the
Okay, so everything we do is eventually available on BioniChaos.com. There should be a link somewhere around the video. So go check out the website. Let us know if you have any questions about any of the tools. If there are technical questions, we'll be actually using them as prompts for future development. Side.